Good morning, dear students. Today I am here with the next video of chapter Electric Currents and Circuits. So let's begin the chapter. Electric current. Dear students, whenever there is a flow of electricity through a wire or a device, we say that electric current is flowing. When we connect a device to the cell, the direction of current flow is taken from its positive terminal to the negative terminal. As you can see in this picture also, the direction of current is from the positive to the negative terminal, whereas the flow of electrons is from negative to the positive terminal, because electrons, they all are negatively charged. They always are negatively charged, and that's why they move towards the positive end of the cell or the battery. So we can now understand why electrical devices have two terminals. The current enters the device through one terminal and leaves it through its other terminal. Now, electric circuit. Electric circuit is a complete and closed path through which an electric current can flow. So, to make a electric circuit, we need a minimum of three parts or elements in the simple electric circuit. So, this is the diagram of the electric circuit where we need minimum three things or three elements. First is the cell. It is the symbol of the cell. A switch, and this pink color line called the wires. These are the three essential elements of the electric circuit. This is the symbol of the bulb. So further we will discuss about the different symbols that are used in a electric circuit. So as you can see here also in the picture, the cell or a battery, the path for the flow of electric current, and a switch. These are the three essential elements that are required in a simple circuit. So here are some different arrangement, and you look carefully in A and F. In these two arrangements, the bulb, they are glowing because of the proper arrangement of the diagram or the circuit, as the wire is connected to the positive as well as to the negative terminal along with to the bulb. So this circuit is working properly, whereas in B and C you can see the wires are loose. They are not connected properly, means there is a break or discontinuity in the path of the electric current. So these two circuits, they are not working properly. Similarly in D also, the wires, they are connected directly to the negative terminal of the battery, so it will also not work. And here in E also, the wires, they are directly connected to the positive terminal of the battery, and this will also not work. So there are certain conditions where the bulb cannot glow. Either the battery may be used up, or the connection may be loose, or you have used the cell or the battery that is already used up, or the filament of the bulb, it is also not working, or maybe it is broken. So there are many conditions under which the circuit cannot work properly. Now, open and closed circuit. Open circuit is the circuit when there is a break or discontinuity in the path, means the switch is in off condition. Here you can see there is a discontinuity in the path of the electric current, so that's why the bulb is not glowing. Whereas in closed circuit, the path is continuously complete, or through this path the electric current is flowing without any hindrance, or there is no break or there is no discontinuity in the path, and this is considered as closed circuit. So what is open circuit? When there is a break or discontinuity in the path of the flow of electric current, it is considered as open circuit. And a complete path through which an electric current is flowing is referred to as closed circuit. Next is a electric switch. Dear students, electric switch is a device which is used in the circuit, and it is an electronic component that can make or break the electric circuit as per your requirement. The switch has two positions: the on position, which completes or closes the circuit and makes the current to flow, and the off position, which breaks or opens the circuit and stops the flow of the current. These electric switches, they come in many different shapes and sizes. As you have seen, the buttons or the type of pieces on the calculators, remotes, computer keyboards, all are switches which are working or used to work in different forms. We also see many different shapes and sizes in our homes or schools or offices. Now, there is one activity in your book that we have to make a simple electric switch. So here we are using a safety pin instead of a electric switch, means this safety pin will work as a electric switch in this circuit. For making this simple electric circuit where we are using a simple electric switch will require a square or a rectangular piece of wood or cardboard, a thin safety pin, and two drawing pins. So we will carefully attach all these things on the cardboard. We will fix two drawing pins at little distance from each other, and put the safety pin at a place such that it is at the one end and is free to rotate about the drawing pin, and its other end make the contact with the other drawing pin. So when we will put in contact, this arrangement will work as a switch is in on position. As you can see in the second condition, when we have put this arrangement in a proper way, the circuit is working and the bulb glows. Whereas here in the first condition, we have not attached the safety pin to the second drawing pin, so the connection is loose or there is discontinuity in the flow of the current and the bulb is not glowing. So that's how we can work or make this electric circuit at home also. So this is the activity which was given in your book. Now the symbols of electric components. So the first symbol, it is donating a cell, where there is a one large line, that is a thin line which donate the positive terminal, and the thicker line and the smaller one is the negative terminal of the cell. This is the symbol of the bulb. It is the symbol of a switch in off position and the switch in on position. This is the symbol of a battery where three cells have been used with thicker and thinner lines. So this will be the positive one and this will be the negative terminal of that battery. And this is the symbol of the wire. And using these symbols, we can make a simple electric circuit diagram. Now conductors. Dear students, what are conductors? Any material that allow electric current to pass through it is known as conductor. For example, copper, aluminium, steel, or any other metal except mercury. These all are conductors. Students, silver is very good conductor of electricity, but it cannot be used for making wire as it is very expensive. So cop- copper was the alternative for this, as copper is also a very good conductor of electricity. Practically all metals, they are good conductor of electricity. Graphite, which is the pencil lead, is also a conductor of electricity. It is a non-metal. It is a carbon component. Insulators. So any material that does not allow electric current to pass through it, like the protective coating on wire, plastic, rubber, glass, cloth, wood, these all are insulators. So these materials, they do not allow electric current to pass through them. That's why your wires or electric wires, they are coated with the plastic covering. Dear students, it has been well said that electricity is a good servant but a bad master. So it is very important to follow all the suggestions and advice or precautions while using the electricity and electrical appliances. Never touch electrical connection with wet hands because you may get electric shock, as water is a good conductor of electricity, and if electricity were to flow through a person's body, it could lead to a serious injury or even death. Never try to open electrical appliances when it is connected to the mains. Always respect the warning signs. Do not go near any setup where there is a word written danger. Always consult the manufacturers or your electricians if you have any doubts about the methods or the way of using electrical appliances. It is also always a good idea to use rubber or plastic gloves while working with electrical devices or connections, because it can save us from many possible electric shocks or electricity related accidents. So that's all for today. Thank you and have a nice day.